Good morning, student. As we described, there are three steps of metallurgy. First is the concentration of ore. Second is the extraction of crude metal from concentrated ore, and the third is the refining of metal. Now let us discuss refining of metal. Refining of metal can be done by one of the following method. The first method of refining of metal is distillation. Student, in distillation process, in this process, the impure metal is evaporated to obtain pure metal as distillate. I repeat again, in distillation process, impure metal is evaporated to obtain pure metal as distillate. This method is employed for low boiling point metal like zinc, etc. Now, let us consider the second method of refining. It is liquation. Second method of refining is liquation. In this method, the low boiling metal like tin can make to flow on a sloping surface. In this method, low boiling metal like tin can make to flow on a sloping surface. Suppose here the impure tin are taken. On heating, pure metal melt first, collected in receiver. It's a pure metal. I repeat again. In liquation method, the low melting metal like tin can make to flow on a sloping surface. The third method of refining is electrolytic refining. Electrolytic refining. In this method, impure metal rod is made to act as anode and the pure metal rod is made to act as cathode. Both electrodes are dipped in suitable electrolyte solution. On passing electricity through its, pure metal from anode dissolves in electrolyte and deposited over cathode, and the impurities settle down below anode is called anode mud or anode sludge. I repeat it again. In this method, impure metal rod is made to act as anode and pure metal rod is made to act as cathode. Both electrodes are dipped in suitable electrolyte solution and electricity is passed through them. The pure metal from anode dissolves in electrolyte and deposited over cathode, and the impurity settled down below anode is called anode mud. It should be noted during electrolytic refining of copper, metal like selenium, silver, gold, platinum, etc. may be obtained from anode mud. Now let us discuss the fourth method of refining. It is zone refining method. Zone refining method is based on the principle that impurities are more soluble in melt than in solid state of metal. I repeat it again. The principle of zone refining method is very important. Generally asked in board examination. I repeat it again. Its principle once again. The zone refining method is based on the principle that zone refining method is based on the principle that the impurities are more soluble in melt than in solid state of metal. In this method, circular heaters are fixed at the one end and the mobile circular heater are fixed at the other hand, which are, as the mobile heater moves forward, as the mobile heaters move forward, impurity melts. As the heater move forward, metal crystallizes as according to this one, and the impurities are collected at the end of the road, and ultimately cut the rod to obtain pure metal. It's a pure metal. It's a impurities. I repeat once again. Zone defining method is based on the principle that impurities are more soluble in melt than in solid state of metal. In this method, circular heater are fixed at the one end, and the another end contain circular mobile heater which moves to and fro direction as the heater moves forward, the pure metal crystallizes out of the melt and the impurity passed on adjacent molten zone. This process repeats several times to obtain metal of very high purity. This method is generally employed for obtaining germanium, gallium, etc. metals of very high purity and also semiconductors. Now let us discuss the fifth method of refining. The fifth method of refining is vapor phase refining method. The fifth method of refining is vapor phase refining method. In vapor phase refining method, first impure metal converted into volatile complex which then decompose to give pure metal. Now let us discuss vapor phase refining method. In vapor phase refining method, impure metal first converted into volatile complex, then decomposed to give pure metal. It, it consists of two parts. Number first part consists of Mond process for refining. Mond process for refining nickel. In this process, impure nickel is heated with a stream of carbon monoxide to form complex tetracarbonyl nickel at 350 Kelvin. Now the complex formed on heating at 450 Kelvin to give pure nickel along with carbon monoxide. So the Mond process is used for refining nickel only. The second part of the vapor phase refining method is Van Arkel method. This method is generally employed for removing impurities from zirconium and titanium metals. In this method, in Van Arkel method, all oxygen and nitrogen present in form of impurity may be removed by heating impure metal with iodine to form metal iodide, then metal iodide on strongly heating at 1800 Kelvin in the presence of tungsten filament give pure metal like this. Now the last but not the least method of refining of metal is the chromatography. The sixth method of refining of metal is chromatography. The basic principle of chromatography is based on the fact that the different component of mixture are differently adsorbed on adsorbent. I repeat it again. The basic principle of chromatography is the different component of mixture are differently adsorbed on adsorbent. Now student, let us discuss some questions. Question number 1. What is the criteria is followed for the selection of stationary phase in chromatography? I repeat it again. What criteria is followed for the selection of stationary phase in chromatography? It should be noted the stationary phase must be immobile and immiscible. The second question is the choice of reducing agent is depend on thermodynamic factor comment. Yes, The choice of reducing agent depends on thermodynamic factor because only those reactions are feasible for which delta G have large negative value. Thank you very much.